Hello, friend. Welcome to Science for Sleep. Did you know that house cats cannot taste sweetness at all? They are missing the proper gene needed to detect sweet flavors. If a cat licks a drop of honey or tastes a piece of fruit, it does not experience sugar the way you do. Its taste system is built for something very different. It is tuned toward meat, toward protein, toward the kind of food a small hunter would find in the wild. And that small hunter is still very much present. The quiet animal resting on a blanket tonight is genetically very close to its wild ancestors. Domestic cats share most of their DNA with the Near Eastern wildcats that once moved through dry grass and open desert. Their bones, their teeth, and even their hunting instincts remain largely unchanged. The soft paws that press into a cushion carry the structure of a predator. The eyes that narrow in dim light once scanned for movement in tall grass. And then there is the sound so many people know well. The low, steady vibration that seems to fill a room without demanding attention. A cat's purr usually falls between 25 and 150 hertz. This range of vibration has been studied in connection with bone strength and tissue repair. Some researchers believe these frequencies may help support healing within the cat's own body. The sound is not only gentle, it is mechanical, rhythmic, and steady. It continues during both inhale and exhale, like a quiet motor that does not turn off. Already, within just a few simple facts, the ordinary house cat begins to feel layered. It cannot taste sweetness. It carries ancient wild ancestry in its DNA. And it hums at frequencies that may support its own bones and tissues. Right now, there are more than 600 million domestic cats living in homes around the world. They sit in kitchens. They stretch across window ledges. They curl into soft circles at the foot of beds. Humans have lived beside them for about 9,000 years, long before modern cities, long before electricity. Even before many of today's languages existed, cats were already sharing space with people. If you enjoy these quiet journeys, you're welcome to subscribe. And if it feels natural, to leave a comment sharing where you're listening from tonight. It helps others find their way to this calm corner of the world, one sleepy traveler at a time. The quiet continues here, just as it is. When you picture a house cat now, you might see something familiar. A small body resting, a tail wrapped neatly around its paws, eyes half closed. But inside that calm shape is a nervous system built for alertness. Cats are crepuscular, which means they are most active at dawn and dusk. Their sleep patterns reflect this. They often rest for 12 to 16 hours each day, conserving energy for short bursts of activity. Even when they appear deeply asleep, their ears may still turn toward faint sounds. Their body temperature runs slightly higher than ours, usually around 38 degrees Celsius. If you have ever felt a cat curled against your side, you may have noticed that warmth. It is steady and quiet. The warmth comes from a metabolism designed for quick movement and rapid response. All of this exists within the small, steady presence of a house cat in a room. A creature that cannot taste sweetness. A creature whose DNA still echoes the wild. A creature whose purr vibrates in a range studied for healing. And yet it chooses to rest on fabric, beside humans, in controlled spaces filled with soft light. As we continue, we will begin to look more closely at the parts of the cat that are easiest to see. the features that help it sense space without touching it, the fine lines that extend from its face, resting lightly against the air. When you picture a cat's face, one of the first things you notice are the long, fine lines extending from either side of the nose. They rest lightly against the air, curving forward in gentle arcs. These are not ordinary hairs. They are called whiskers, or vibrissae, and they are among the most sensitive structures on a cat's body. Each whisker is rooted much deeper than normal fur. Beneath the skin, the base of every whisker sits inside a follicle that is packed with nerve endings. These follicles are surrounded by tiny muscles and filled with blood, which helps transmit even the smallest movement. When a whisker shifts slightly, that movement is detected almost instantly by the nervous system. The whisker itself does not feel, but the base of it does, and it feels very clearly. If you imagine a cat walking slowly through a dim hallway at night, you might picture its body moving quietly across the floor. The lights are low. Shadows stretch long across the walls. The cat does not rely only on its eyes. As it moves forward, its whiskers gently brush against currents of air. They detect subtle changes in pressure. Even before the cat touches an object, it can sense that something is there. Whiskers help a cat measure space. In many cases, the length of a cat's whiskers roughly matches the width of its body. This allows the cat to judge whether it can fit through a narrow opening. Before squeezing into a gap between furniture or stepping into a small space, the whiskers act like measuring tools. If the whiskers press firmly against the surface on both sides, the cat receives a clear signal that the opening may be too tight. There are whiskers on the sides of the nose, but also above the eyes, on the chin, and even along the back of the front legs. The whiskers above the eyes help protect the face. If something brushes against them, the cat may blink before the object ever reaches its eye. The whiskers on the legs help detect the movement of prey during hunting. In the wild, these small sensory hairs allowed cats to feel vibrations from an animal moving through grass or across soil. Whiskers can also move forward and backward. When a cat becomes curious or alert, the whiskers often angle forward. When relaxed, they may rest more to the sides. Under stress, they can pull back tightly against the face. These subtle changes in position reflect shifts in attention and emotion. The movement is small, sometimes almost invisible, but it carries information. Because whiskers are so sensitive, they should never be trimmed. Cutting them does not cause pain in the hair itself, but it removes an important sensory tool. Without full-length whiskers, a cat may become disoriented. Its ability to judge distance and space becomes less precise. In a quiet room, this may not seem dramatic, but for an animal built to move quickly and navigate tight spaces, the loss is meaningful. Even in a modern home, where walls are stable and furniture rarely moves, whiskers continue to work constantly. They monitor airflow from open windows. They sense the approach of a hand. They register small vibrations from footsteps across the floor. Much of this information happens below the level of conscious thought. The cat does not pause to analyze it. The signals simply travel from whisker base to brain, shaping tiny adjustments in posture and movement. If you watch a resting cat closely, you may see the whiskers twitch during sleep. During REM cycles, When brief dreams may occur, the face can flicker with subtle motion. The whiskers shift slightly, as if responding to something unseen. The body remains still, but the sensory system continues its quiet work. The fine lines that frame a cat's face are not decoration. They are extensions of perception. They allow the animal to feel the shape of space without touching it. In dim light, in silence, in stillness, the whiskers remain alert. And in their quiet way, they reveal just how detailed a cat's experience of the world can be. Just beyond the quiet frame of the whiskers, your eyes might drift toward another part of the cat that rarely stays completely still. The tail moves in slow arcs. It curls neatly around paws. It flicks once, then rests again. Even in sleep, it may give a small twitch, as if finishing a thought that never needed words. A cat's tail is not a simple decoration. It is an extension of the spine. Inside it are additional vertebrae, usually between 18 and 23 small bones that continue from the main backbone. These bones are connected by joints, muscles, tendons, and nerves, allowing the tail to bend, lift, curve, and sway with great control. When you see a tail rise gently into the air, you are watching a flexible structure that is directly linked to the central skeleton. Because the tail is connected to the spine, it plays an important role in balance. Imagine a cat walking along the narrow top of a fence. Its paws place themselves carefully in a line. The body moves forward with quiet precision. As the cat shifts slightly to one side, the tail moves in the opposite direction. This counter movement helps stabilize the body. It acts as a counterweight, adjusting in real time to keep the center of gravity steady. These changes happen in fractions of a second, guided by signals traveling quickly through the nervous system. This balancing function becomes even more important during a jump. Cats can leap several times their own body length, powered by strong hind legs and elastic tendons that store energy before release. As the body rises into the air, the tail helps control rotation. Small twists of the tail adjust the angle of the body mid-flight. This works alongside a well-known reflex called the righting reflex, which allows cats to orient themselves feet down during a fall. The tail is not the only part involved in this process, but it assists by fine-tuning balance and direction as gravity pulls the body downward. If you picture a cat landing softly on the floor, the tail often lifts or curves slightly at the moment of impact. That final adjustment helps absorb force and maintain stability. The movement is subtle, but it reflects constant communication between muscles, inner ear balance systems, and the spine. The tail also communicates emotion. When a cat approaches you with its tail held upright, sometimes with a slight curve at the tip, it is often signaling friendliness or confidence. Kittens greet their mothers this way. Adult cats greet trusted humans in a similar posture. If the tail puffs up and becomes larger in appearance, that usually indicates fear or a defensive state. The fur stands on end due to a response in the nervous system called piloerection, which is triggered by adrenaline. This makes the cat appear bigger to a perceived threat. A slow, steady swish of the tail can indicate focused attention. You might see this when a cat watches a bird outside a window. The body remains still, eyes locked forward, while the tail moves gently from side to side. Faster flicking especially at the tip, can signal irritation or overstimulation. These movements are small but meaningful. They are part of a quiet language that does not require sound. Inside the tail run nerves that carry signals from the spinal cord outward. Because of this, injury to the tail can sometimes affect nearby nerve pathways. This reminds us again that the tail is not separate from the body. It is integrated deeply into the cat's overall structure. Even in rest, the tail rarely loses its purpose. Curled around the body during sleep, it helps conserve warmth. Wrapped close against the nose, it may shield the face from light or drafts. The average body temperature of a cat is around 38 degrees Celsius, slightly warmer than a human's. That warmth radiates outward, and the tail, when wrapped close, becomes part of a small circle of retained heat. When you observe a cat from across a room, the tail may seem like a simple, gentle shape moving against still air. But within that shape are vertebrae, muscles, nerves, balance systems, and emotional signals all working together. The tail steadies the body during narrow walks. It adjusts rotation during leaps. It reflects shifts in feeling without a single sound. And as the cat settles once more, tail folding softly against its side, the motion slows again into quiet stillness. As the tail settles and the body becomes still again, your attention may rise naturally toward the cat's eyes. In soft light, they appear wide and reflective. In brighter light, the pupils narrow into thin vertical lines. The eyes of a house cat are built not only to see, but to see well in conditions where human vision begins to struggle. Inside the back of a cat's eye is a special layer called the tapetum lucidum. This layer acts like a mirror. When light enters the eye, it passes through the retina and strikes this reflective surface. Instead of being lost, the light is reflected back through the retina a second time. This gives the light-sensitive cells another chance to detect it. That is why a cat's eyes can seem to glow when caught in a beam of light at night. The glow is not coming from the cat. It is light bouncing back outward. Because of this reflective layer, cats can see in light levels that are much lower than what humans require. Their eyes are especially rich in rod cells. Rods are photoreceptor cells that detect movement and light intensity. Humans also have rods, but cats have a higher proportion of them. This allows them to detect motion in dim environments. While humans may notice shapes fading as darkness deepens, a cat can still register subtle shifts in movement. The pupil of a cat's eye is also designed for control. In bright daylight, the pupil narrows into a vertical slit. This shape helps reduce the amount of light entering the eye, while still preserving depth perception. In low light, the pupil can expand dramatically, becoming wide and round. This large opening allows as much light as possible to reach the retina. The change can happen quickly, adjusting within moments as lighting conditions shift. If you imagine a room at dusk, shadows stretching across the floor, you may picture a cat sitting quietly near a window. The sky outside grows darker. The pupils widen slowly, taking in what little light remains. The body does not need to move. The eyes adjust on their own. While cats see well in low light, their color vision is different from ours. They have fewer cone cells, which are responsible for detecting color. As a result, their world likely appears more muted. They are thought to see blues and yellows more clearly than reds and greens. Fine detail is also less sharp compared to human vision. A cat relies more on motion than on small visual textures. This focus on motion fits their evolutionary history. In the wild, detecting the quick movement of a small animal at dusk could mean the difference between eating and going hungry. Even in a modern home, this sensitivity remains. A tiny shift in a curtain, a faint movement across the floor, a flicker of shadow on a wall. The eyes notice. Cats also have a wider field of vision than humans. Their eyes are positioned forward, allowing depth perception, but they also extend slightly to the sides. This gives them a broad view of their surroundings. While humans see roughly 180 degrees around them, cats can see closer to 200 degrees. This wider range helps them remain aware of potential threats or movement at the edges of their vision. If you watch a cat closely while it rests, you may see its eyes half close in what looks like calm contentment. But even then, the eyes may open slightly at the faintest sound or motion. During light sleep, the visual system remains partially alert. In deeper REM sleep, the eyes may move beneath closed lids, reflecting internal brain activity as brief dreams unfold. The surface of a cat's eye is kept moist by a thin tear film. Blinking spreads this layer evenly, protecting the cornea and maintaining clarity. Unlike humans, cats blink less often during focused attention. A steady, unbroken gaze may signal alertness. A slow blink, on the other hand, can signal trust and relaxation. This subtle exchange between vision and emotion forms part of the quiet language between cats and humans. In dim rooms and soft light, the eyes of a house cat become instruments of still awareness. They gather faint light. They reflect it back. They widen and narrow in response to changing brightness. They detect motion where others might see only shadow. And as darkness deepens, the world for the cat does not disappear. It simply softens, remaining visible in quiet detail. As the light softens and the eyes adjust, another part of the cat continues its quiet work. Just above the face, two small shapes shift almost constantly. The ears turn, tilt, and pause. Even when the body appears still, the ears often move on their own, responding to sounds that may not even reach your awareness. A cat's ears are controlled by an impressive network of muscles. Each ear has around 32 small muscles attached to it. These muscles allow the ears to rotate up to 180 degrees. Unlike human ears, which remain fixed in place, a cat's ears can swivel independently. One ear may turn toward a faint sound in the hallway, while the other remains focused on something near a window. This movement is not random. It is guided by highly sensitive hearing. Cats can detect frequencies up to about 64,000 hertz. Humans, by comparison, typically hear up to around 20,000 hertz. That means a cat can hear sounds far higher in pitch than we can. Many small rodents communicate in ultrasonic ranges. A cat's hearing evolved to detect these high-frequency signals. If you imagine a quiet house at night, you might picture complete silence. But for a cat, the silence is layered with subtle detail. The hum of distant electrical currents, the faint scurrying of something outside a wall, the soft rustle of fabric shifting in another room. Sounds that seem absent to us may stand out clearly to them. The shape of the ear itself also plays a role. A cat's ear has a wide opening that funnels sound inward. Inside, sound waves travel down the ear canal toward the eardrum. Vibrations move through tiny bones in the middle ear, then into the inner ear, where hair cells convert mechanical motion into electrical signals. These signals travel along the auditory nerve to the brain. All of this happens in fractions of a second. Because their hearing is so acute, cats often respond before humans even notice a sound. You may see the ears twitch or pivot suddenly. The body may remain relaxed, but the ears shift toward the source. This is a sign of selective attention. The cat does not need to move its entire body to gather information. The ears do much of the early work. Cats are also skilled at filtering background noise. In environments filled with steady sounds, such as a fan or distant traffic, their brains learn to tune out constant input. Instead, they focus on sudden changes or irregular patterns. This ability helps them conserve energy. They do not react to every sound, only to those that stand out. Even during rest, the ears often continue to adjust. In light sleep, they may turn toward a soft footstep or the faint click of a door. During deeper REM sleep, the body relaxes more fully, but the auditory system remains capable of quick activation. This balance between rest and readiness reflects their evolutionary history as both predator and potential prey. The ears also play a role in communication. When relaxed and upright, they suggest calm alertness. When angled slightly forward, they may signal curiosity. Flattened ears pressed close to the head often indicate fear or defensive behavior. The position changes the silhouette of the head, sending visual signals to other animals without requiring sound. If you watch a cat sitting in a quiet room, you might notice that the ears move more than any other visible feature. They scan the environment in slow rotations. They pause. They adjust again. It is a steady rhythm of monitoring. The movements are small but constant. There is also a structure on the outer edge of the ear called the pinna. The pinna helps capture and direct sound waves into the ear canal. Its curved shape increases the efficiency of sound collection. Because of this design, cats can pinpoint the direction of a sound with impressive accuracy. Even slight differences in timing between the two ears allow the brain to calculate where a sound originates. In stillness, the ears remain active. They turn without drama. They respond without urgency. They gather information from the air itself. And even when the room feels silent to you, the world continues to whisper softly into the attentive shape of a cat's listening ears. When the ears settle and the room grows quiet again, you might notice the shape of the cat's body as it rests. At first glance, it looks soft, relaxed, folded into itself. But even in stillness, there is a subtle sense of readiness. The back curves gently. The legs tuck beneath the body. The spine forms a smooth arc, like something lightly coiled. Beneath the fur is a structure built for motion. A cat's spine is remarkably flexible. It contains roughly 30 vertebrae, more than the average human spine. These vertebrae are connected in a way that allows for a wide range of motion, When a cat stretches forward, you may see the back lengthen almost like an accordion unfolding. When it crouches, the spine compresses again, storing potential energy within its curved shape. This flexibility plays a key role in how cats move. During a run, the spine bends and extends with each stride. As the body stretches forward, the hind legs push off the ground. Then the spine compresses, drawing the legs back underneath. This motion increases stride length without requiring longer limbs. It allows for speed in short bursts, which suits a predator that hunts in brief, focused moments rather than long chases. If you look closely at the legs, you may notice another small detail. The hind legs are slightly longer than the front legs. This difference creates a natural forward tilt when the cat stands. It also provides extra power during jumps. The muscles in the hindquarters are dense and strong, built to generate quick force. When a cat prepares to leap, it lowers its body, folding those longer hind legs beneath it. The spine curves, the muscles tighten. Then, in a single movement, the body launches upward. Inside those muscles are a high proportion of fast-twitch fibers. These fibers are designed for speed and rapid contraction. They allow for quick acceleration, sharp turns, and sudden pounces. Fast-twitch fibers generate power, but they tire more quickly than slow-twitch fibers. This is one reason cats are built for short, intense activity, followed by long periods of rest. Their bodies are designed for efficiency, not endurance. Now consider the pause. When a cat walks across a floor, you rarely hear it. That quiet movement is partly due to soft paw pads that absorb impact, but it is also due to retractable claws. Unlike many animals, cats can draw their claws inward when not in use. The claws rest sheathed within the toes, protected from wear. This keeps them sharp for climbing or gripping prey. When needed, small tendons extend the claws outward. When relaxed, the claws retract again. The face, too, reflects predatory design. The eyes sit forward on the head, rather than on the sides. This positioning allows for depth perception. Both eyes focus on the same object, and the brain combines the images to judge distance. When a cat prepares to jump, it calculates space carefully. The angle, the height, the landing point. Forward-facing eyes help guide that precision. Even in calm domestic spaces, these traits remain visible. A cat perched on the back of a couch may look peaceful, but the spine beneath that calm posture is flexible and strong. The legs are aligned for sudden motion. The claws remain protected and ready. The eyes track movement without effort, and yet, much of the time, that readiness does not turn into action. The body rests, the muscles soften, the fast-twitch fibers lie still. This is part of the design as well. A system built for short bursts must conserve energy in between. The small predator does not waste movement. It waits. If you watch a cat stretch after waking, you may see the full length of its spine extend once more. The back arches upward, then lowers. The front legs reach forward while the hind legs extend behind. This stretch increases blood flow to the muscles and resets posture after rest. It is a quiet reminder of the power that lives beneath stillness. In the end, the shape of a house cat carries both softness and structure. It appears gentle, but it is built for precision. It appears relaxed, but it is designed for speed. And because its energy comes in short, powerful waves, it must also spend long hours conserving that energy in quiet rest. After the stretch fades and the muscles soften again, the body often returns to stillness. If you picture a house cat now, it may be curled into a compact shape, paws tucked beneath the chest, tail wrapped gently along the side, eyes closed or half closed, as if watching the world from behind a thin curtain of rest. Cats sleep far more than most humans. On average, a healthy adult cat sleeps between 12 and 16 hours each day. Some may sleep even longer, especially kittens and older cats. This does not mean they are always in deep, unbroken sleep. Much of their rest is light. Their ears may still turn toward faint sounds. Their whiskers may twitch. Their body remains ready to wake within moments. This pattern reflects their evolutionary history. Cats are crepuscular, which means they are naturally most active at dawn and at dusk. These are the times when many small prey animals are also active. In the soft light of early morning or fading evening, a cat's senses are especially well suited to detect motion. During the middle of the day and the deeper parts of the night, energy use decreases. The body rests. Because of this pattern, a cat's sleep is often divided into many smaller segments rather than one long stretch. Light sleep dominates. In this stage, brain activity slows slightly, but awareness does not disappear. A sudden sound can bring the cat upright within seconds. The transition from sleep to alertness is quick. Muscles engage almost instantly. The spine straightens. The eyes open wide. Cats also experience REM sleep, though in shorter cycles than humans. During REM sleep, brain activity becomes more active. This stage is associated with dreaming in many mammals. You may notice a cat's paws twitching, whiskers flickering, or eyes moving beneath closed lids. These small movements suggest internal activity in the brain, even while the body lies still. REM cycles in cats tend to last only a few minutes at a time, but they occur multiple times throughout the day. Energy conservation is one of the main reasons cats sleep so much. Their bodies are built for short bursts of high power, as we have already seen. Fast-twitch muscle fibers allow them to jump and sprint quickly, but those bursts require fuel. By resting for long periods, they reduce overall energy use. In the wild, this strategy ensures that when an opportunity to hunt appears, the body is ready to respond. In a home environment, the need to hunt may be replaced by play or exploration, but the biological rhythm remains. A cat may spend hours resting in a sunbeam, absorbing warmth. Body temperature in cats averages around 38 degrees Celsius. Warm environments help reduce the need to generate extra heat, further conserving energy. Sunlight across the fur becomes a natural blanket. If you observe a sleeping cat closely, you may notice different postures. When lightly asleep, the body may remain upright, with paws tucked beneath. When deeply asleep, the cat may roll onto its side or even onto its back, exposing its belly. This position often indicates a sense of safety. The muscles loosen more completely. The breathing becomes slower and more regular. Breathing during sleep is steady and quiet. The chest rises and falls in a smooth rhythm. In deeper rest, the body systems slow slightly. Heart rate decreases, muscles relax. Yet even then, the sensory systems never fully shut down. The ears remain capable of detecting sound. The nose can register scent changes. The balance between rest and readiness continues. Because their sleep is spread throughout the day, cats often align their rest with the patterns of the household. They may sleep more during quiet hours and become active when movement increases. Some adjust their rhythm slightly to match feeding times or familiar routines. This flexibility shows how ancient biological patterns can adapt to domestic life. And so, the small predator spends much of its day in stillness, coiled, warm, conserving energy. The spine that can bend and launch rests softly against fabric. The fast twitch muscles lie quiet beneath fur. The eyes close, but not completely. Sleep comes in gentle waves, light and deep, repeating again and again. As the body settles further, breathing grows softer, and from that steady breath, another quiet sound sometimes begins to rise. As the breathing settles into a slow and steady rhythm, another sound sometimes begins to form beneath it. It is low, even, almost mechanical in its consistency. The sound does not rise or fall sharply. It hums. This is the purr. Unlike many animal sounds that are produced only during exhale, a cat's purr continues during both inhale and exhale. The vibration remains steady as air moves in and out of the lungs. This is made possible by small muscles in the larynx or voice box. These muscles contract and relax in a rapid, rhythmic pattern. As they do, they cause the vocal cords to separate slightly and then come together again in quick cycles. Air passing through this movement creates the familiar vibrating sound. The frequency of a typical cat's purr usually falls between 25 and 150 Hz. Hertz is simply a measure of vibration per second. Lower numbers feel deeper and more resonant. Within this range, the vibration is not sharp or high. It is soft and steady. When you place a hand gently against a purring cat, you may feel the vibration travel through its chest and into your palm. Researchers have studied this frequency range because vibrations between roughly 20 and 150 Hz have been associated with bone strength and tissue repair in some laboratory settings. While the exact effects of purring are still being explored, some scientists believe that these vibrations may help support healing within the cat's own body. It is possible that the purr serves not only as communication, but also as a subtle form of physical regulation. Cats begin purring very early in life. Kittens can produce soft purring sounds within days of birth. This vibration may help guide them toward their mother while nursing. It also signals contentment and safety. The mother cat may purr in return, creating a shared vibration between them. In this way, purring becomes linked to comfort from the beginning. But purring does not only occur during calm moments. Cats sometimes purr when they are frightened, injured, or stressed. Veterinarians often notice purring during medical examinations, even when a cat appears uneasy. This suggests that purring may serve multiple purposes. It can signal relaxation. It can signal reassurance. And it may help regulate the nervous system during discomfort. The sound itself is not loud. It rarely demands attention. Instead, it blends into the background of a room. Its repetition is part of what makes it soothing. The rhythm does not change suddenly. It continues at a consistent pace, like a quiet engine idling without interruption. If you watch a cat while it purrs, you may notice small physical signs. The throat may flutter slightly. The chest may vibrate. The whiskers may tremble faintly with each cycle. Yet the rest of the body can remain completely relaxed. The eyes may close. The tail may rest without movement. The purr becomes part of the atmosphere. Because the purr continues during both inhale and exhale, it creates a continuous loop of sound. This makes it different from many other vocalizations in the animal world. There is no gap between breaths. The vibration carries across the entire breathing cycle. Some researchers believe that the rhythmic quality of purring may also influence humans. Repetitive, low-frequency sounds can encourage a calming response in the human nervous system. The steady pattern provides predictability. There are no sudden spikes or sharp tones. The body may begin to mirror that steady rhythm. If you imagine a quiet evening room with a cat resting nearby, the purr may blend with the faint sounds of the environment. The hum of distant air, the soft shift of fabric, the slow breath rising and falling. The vibration becomes part of the stillness rather than interrupting it. Inside the cat's body, the small muscles of the larynx continue their rapid cycle of contraction and release. Air moves smoothly through the vocal cords. The chest resonates gently. The frequency remains within that familiar range, steady and even. Repetition creates stability. Stability encourages regulation. And in that ongoing vibration, the small predator built for bursts of speed settles into something entirely different. A steady hum, a rhythmic pulse, a quiet form of balance that continues as long as the breath flows in and out. After the steady vibration of the purr, another quiet behavior often follows. The head lowers slightly, the tongue extends. A slow, careful stroke moves across the fur. Then another, and another. Grooming begins. Cats spend a large portion of their waking hours grooming themselves. Studies suggest that an adult cat may devote between 30 and 50% of its awake time to this repetitive activity. If you picture a cat resting in a patch of light, you might see it pause, lift one paw, and begin to lick with steady rhythm. The motion appears simple, but it serves many purposes. A cat's tongue is not smooth. It is covered in tiny, backward-facing structures called papillae. These papillae are made of keratin, the same material found in human fingernails. Under close examination, they look like small curved hooks. When the tongue moves through the fur, these hooks catch loose hair and debris. They also help remove small particles and parasites from the coat. The design of the papillae allows the tongue to act almost like a comb. Each stroke separates the fur and reaches down toward the skin. This helps distribute natural oils produced by glands in the skin. These oils keep the coat flexible and slightly water-resistant. Even in indoor cats, this grooming habit remains strong. Grooming also helps regulate body temperature. When a cat licks its fur, saliva spreads across the surface. As that moisture evaporates, it cools the body slightly. This is especially useful in warmer environments. Because a cat's average body temperature is around 38 degrees Celsius, small cooling adjustments can help maintain balance. Beyond hygiene and temperature control, grooming appears to play a role in stress reduction. The repetitive motion of licking and cleaning can lower stress hormones in the body. After a brief conflict or a surprising noise, a cat may begin grooming almost immediately. This behavior, sometimes called displacement grooming, may help the nervous system return to a calmer state. The motion is predictable. The rhythm is steady. The focus shifts inward. If you observe closely, you may notice that grooming often follows excitement. After a burst of play or a quick sprint across the room, a cat may sit down and begin cleaning itself. The body transitions from movement to stillness. The fast twitch muscles that powered the sprint relax. The breathing slows. The tongue moves in repeated strokes, smoothing fur and re-establishing order. Grooming patterns can also reveal subtle changes in health. Excessive grooming in one area may indicate irritation or discomfort. Reduced grooming, especially in older cats, may suggest stiffness or fatigue. Because grooming is such a constant part of feline life, changes in this behavior can be meaningful signals. The sequence of grooming often follows a pattern. A cat may begin with the front paws, licking them carefully before wiping them over the face and ears. Then it may move to the chest, sides, and back. The hind legs lift, one at a time, as the tongue reaches toward the belly. The movements are deliberate and flexible, supported by the same adaptable spine that allows for jumping and stretching. Kittens learn grooming behavior early by watching their mother. The mother cat licks her kittens to clean them and stimulate circulation. Over time, the kittens begin to groom themselves. This early experience connects grooming with safety and care. The behavior becomes part of daily life. In multi-cat households, grooming can also become social. One cat may lick another around the head or neck. This shared grooming, sometimes called allogrooming, strengthens bonds and reinforces group stability. It is another quiet form of communication. In the stillness of a room, the sound of grooming is faint. A soft rasp of tongue against fur, a brief pause, another stroke. The body curves gently to reach each area. The eyes may half close in concentration. The small predator built for motion now moves slowly, deliberately. The claws remain sheathed. The ears stay relaxed. The purr may continue quietly beneath the rhythm of licking. Within these repeated motions lies both biology and regulation. Keratin hooks clearing fur, saliva cooling skin, hormones shifting gently downward. The world outside grows less important as the focus narrows to the simple act of cleaning. And in that narrowing, something familiar begins to echo. A rhythm learned early in life, a motion tied to comfort, a behavior that reaches back to the first days of kittenhood. Within the steady rhythm of grooming, there is another movement that feels even more familiar. The front paws press down slowly, one at a time. The toes spread slightly. The claws may extend just a little, then retract again. The motion repeats in an alternating pattern, left, right, left, right. This behavior is known as kneading. If you picture a cat resting on a soft blanket or cushion, you may have seen this gentle pressing. The paws move forward and downward into the fabric. The shoulders shift slightly with each push. The body remains mostly still, but the front legs work in a slow, steady rhythm. Kneading begins very early in life. Kittens knead their mother's belly while nursing. This pressing motion helps stimulate the flow of milk. The behavior is paired with warmth, safety, and nourishment. In those early days, kneading is connected to comfort and survival. As the kitten grows into an adult cat, the behavior often remains. Even though milk is no longer part of daily life, the motion continues in moments of relaxation. The nervous system appears to link kneading with the calm state that once surrounded feeding. The pattern remains stored in muscle memory. There are scent glands located in a cat's paws, especially around the pads. When a cat kneads a surface, it may also be marking that area with its scent. The scent is not strong to human noses, but to a cat, it carries meaning. It signals familiarity and ownership. The soft blanket becomes part of the cat's known territory. The movement itself is rhythmic. The paws press down, then release. Press down, then release. This repetition can last for several minutes. During kneading, the eyes may close halfway. The body may begin to purr. The tail often rests quietly along the side. Inside the body, the motion is supported by coordinated muscle contractions in the shoulders and forelimbs. Tendons in the toes extend and retract the claws automatically. Even when the claws are lightly extended, they are usually not used for scratching during kneading. The motion is controlled and deliberate. The texture of the surface often influences kneading. Cats tend to choose soft materials such as blankets, clothing, or cushions. These surfaces resemble the warmth and softness of a mother's fur. The pressure of the paws into soft fabric provides sensory feedback through the pads, reinforcing the calming cycle. In some cases, kneading may also trigger the release of calming hormones. While research continues in this area, repetitive, rhythmic behaviors in many animals are linked to reduced stress levels. The body shifts into a more regulated state. Heart rate slows slightly. Breathing becomes steady. If you observe carefully, you may notice that kneading often happens during times of safety. A cat kneads when it feels secure in its environment. The body posture remains relaxed. The ears are neutral. The whiskers rest gently outward. There is no sign of tension. The action also reflects how deeply early development shapes adult behavior. A simple motion learned during the first weeks of life continues for years. The connection between comfort and movement remains strong. In multi-cat households, kneading may occur near other cats as well. The behavior can signal trust and contentment within shared space. It does not require sound. The movement alone communicates a state of ease. If the claws extend more than expected, it is not usually aggression. It is part of the natural reflex built into the motion. The tendons that control claw extension are linked to the same muscles used for pressing. Over time, kneading slows. The paws press more gently. The body leans into the surface. The purr may deepen slightly. The cat may shift into a resting position, curling inward once more. What began as a nursing reflex becomes an adult ritual of calm. The small predator built for quick motion returns to a behavior rooted in infancy. The paws press softly against fabric. The shoulders move in quiet rhythm. The body remembers something simple and steady. And in that repeated motion, comfort lingers, carried forward from the earliest days into the quiet present moment. After the slow rhythm of kneading fades and the pause grows still, there is often a different kind of movement that follows at some point in the day. It happens quickly, so quickly that the eye almost misses the beginning of it. The body lowers slightly. The hind legs fold beneath. The spine curves. And then, in one smooth release, the cat lifts from the ground. A healthy adult cat can leap 5 to 6 times its own body length in a single bound. For a cat that measures only a few feet from nose to tail, that distance is remarkable. Yet the jump does not appear forced. It looks fluid, effortless. The body gathers energy and releases it in one continuous motion. The power of the jump begins in the hind legs. As we have seen, the back legs are slightly longer than the front legs. This length difference gives the hindquarters more leverage. When preparing to leap, the cat lowers its body into a crouch. The joints in the hips, knees, and ankles flex deeply. Muscles in the thighs tighten and hold tension for a brief moment. Inside those muscles are strong, fast-twitch fibers. These fibers contract rapidly and generate powerful force. They are built for speed rather than endurance. When the signal from the brain arrives, the muscles extend all at once. The hind legs push forcefully against the ground. At the same time, the spine begins to extend, lengthening the body forward and upward. The spine plays an important role in the jump. Its flexibility allows the body to compress and then expand. When compressed, it stores potential energy like a coiled spring. As it extends, it adds momentum to the leap. The front legs reach forward to prepare for landing. The tail adjusts balance in mid-air. Elastic tendons also assist in this movement. Tendons connect muscles to bones, and in a cat's hind legs, some of these tendons can store and release energy efficiently. When the cat crouches, energy is loaded into the tendons. When the jump begins, that stored energy is released, adding extra force without requiring additional muscle effort. If you watch closely as the cat moves through the air, you may see small adjustments. The tail shifts slightly to maintain balance. The front paws extend toward the landing point. The eyes remain focused. Forward-facing eyes allow depth perception, helping the cat judge distance accurately before takeoff. Then comes the landing. The front paws make contact first, followed by the hind paws. The joints flex immediately, absorbing impact. Soft paw pads cushion the force. The body lowers gently, and the spine curves once more to stabilize. What could have been a loud collision becomes a quiet arrival. The jump is not only vertical. Cats can also spring sideways or forward with great precision. In playful moments, they may twist mid-air to change direction. This control is linked to the righting reflex, which we touched on earlier. Even during short jumps, the nervous system constantly monitors body position using input from the inner ear and muscles. Adjustments happen instantly. In domestic spaces, these jumps may take place between couches, onto shelves, or up to windowsills. In the wild, similar leaps once carried cats over rocks and through brush. The environment has changed, but the mechanics remain the same. Despite their ability to leap so powerfully, cats rarely jump without purpose. They assess before acting. You may see a cat pause, studying the height of a surface. The body lowers slightly as it calculates distance. The eyes narrow. The muscles gather tension. Only when the position feels correct does the movement begin. This pattern reflects efficiency. The fast twitch muscles that power the jump require energy. They are not meant for constant activity. After 1 or 2 bursts, the body often returns to rest. The predator's design favors precision over repetition. In stillness, the power remains hidden. The legs appear slim. The back seems soft. But beneath the fur lies a system of muscle, tendon, bone, and reflex working together with exact timing. And after the leap is complete, after the body settles again onto a quiet surface, the muscles relax. The spine softens. The tail comes to rest. Energy has been used in a brief, focused moment. And just as quickly, conservation begins again. Picture a cat moving slowly through a familiar room. The light is soft. The air feels still. The cat pauses beside a table leg and gently turns its head, brushing its cheek along the edge. It moves forward a few steps, then presses its face lightly against the doorway. The motion is small and quiet, but it carries meaning. Along a cat's cheeks are facial glands that produce scent. These glands release chemical signals that other cats can detect easily, though humans usually cannot smell them. When a cat rubs its face against furniture, walls, or even a person's hand, it is depositing these scent markers. The surface becomes part of the cat's known space. For a cat, territory is defined more by smell than by sight. Humans often rely heavily on vision to understand a room. We see walls, corners, doors, and windows. A cat senses these boundaries too, but it also perceives invisible scent trails layered across the environment. The house becomes a network of familiar signals. When a cat moves from one room to another, it is not entering a blank space. It is stepping into an area that carries its own scent history. The couch, the chair, the doorway, the baseboards, each may hold faint chemical markers placed during previous passes. These markers create continuity. They tell the cat that this space is safe and recognized. Research has shown that familiar scent can lower cortisol levels in cats. Cortisol is a hormone associated with stress. When a cat is exposed to unfamiliar smells or sudden environmental changes, cortisol levels can rise. But when surrounded by its own scent, or by the scent of trusted individuals, the body tends to remain calmer. The environment feels stable. This is one reason cats often rub against people. The motion transfers scent onto the human and gathers the human scent onto the cat. The exchange strengthens familiarity. It is not simply affection, though affection may be part of it. It is also environmental mapping. Cats build detailed mental maps of the spaces they live in. These maps are not only visual, they are spatial and sensory. A cat knows where furniture stands. It remembers the height of surfaces. It learns the sound patterns of floors and the airflow near windows. Over time, the brain forms a consistent internal model of the home. Mapping reduces stress because it reduces uncertainty. When a cat knows the layout of a room, it can predict where obstacles are located. It can calculate the distance between surfaces before jumping. It understands which areas are quiet and which carry more movement. The nervous system relaxes when the world feels predictable. If furniture is rearranged suddenly, you may notice a cat pausing more often. It may sniff corners carefully or walk slowly along new paths. The mental map must update. The scent lines shift. Until the map feels complete again, alertness may increase slightly. Even vertical spaces are included in this map. Shelves, counters, and window ledges become part of a three-dimensional territory. Cats often seek higher ground because it provides a wider view and a sense of control. From an elevated surface, the room can be observed without direct engagement. When multiple cats share a home, territory becomes layered. Each cat may deposit scent in slightly different areas. Over time, a shared network of scent develops. This shared scent can help maintain group stability when relationships are calm. If you watch a cat pause in a hallway, nose slightly raised, it may be sampling the air for subtle chemical cues. The vomeronasal organ, located in the roof of the mouth, allows cats to process certain scent signals more deeply. A brief open mouth expression, sometimes called the Flamen response, can appear as the cat analyzes scent information. To the human eye, the house is made of walls and furniture. To the cat, it is structured by invisible lines of familiarity, cheek marks on corners, paw scent on blankets, the faint trace left on a favorite chair. As the cat moves quietly from one place to another, it is guided by this network of scent. The walls feel less like barriers and more like markers within a larger pattern. The house becomes a map written in scent, guiding the small predator gently from room to room, along paths only it can fully sense. Imagine the quiet of a room resting undisturbed. The air is still. Light settles gently across the floor. Then a small sound rises, clear but not sharp. A single meow. Unlike the low vibration of a purr, a meow carries more shape. It begins, lifts slightly in tone, and then fades. It asks for attention, but softly. And interestingly, this sound is not used very often between adult cats. In natural settings, adult cats rarely meow to one another. Kittens meow frequently to their mothers, especially in the first weeks of life. The sound signals need, hunger, cold, separation. The mother responds by locating and retrieving the kitten. But as cats grow into adulthood, meowing toward other cats becomes less common. Instead, adult cats rely more on body language, scent, posture, and subtle vocalizations, like hissing or growling when necessary. Meowing, as we often hear it in homes, is directed mainly at humans. Over time, domestic cats appear to have adapted this kitten-like vocalization specifically for communication with people. The pitch of many meows falls within frequency ranges that resemble human infant cries. Humans are naturally sensitive to these frequencies. They draw attention without needing to be loud. This may be one reason a meow can feel hard to ignore. Unlike a purr, which is produced by rhythmic muscle contractions in the larynx, a meow is shaped more like typical vocal speech sounds. Air passes through the vocal cords, and the mouth opens and closes to form the sound. The length and tone vary from cat to cat. Meowing is largely a learned behavior. Cats quickly discover that certain sounds produce certain responses from humans. A soft meow near the food bowl may result in feeding. A short, repeated meow near a door may lead to it being opened. Through repetition, the cat begins to adjust its vocal patterns to achieve predictable results. Individual cats often develop distinct meow patterns. Some produce short, high-pitched sounds. Others use longer, drawn-out tones. The rhythm can change depending on context. A greeting meow may sound different from a request. Over time, many people become able to recognize subtle differences in their own cat's vocalizations. If you observe closely, you may notice that a cat often pairs a meow with eye contact. The sound is not sent into empty space. It is directed. The forward-facing eyes lock briefly onto the human's face. The ears may angle forward. The tail may lift slightly. The entire body participates in the communication. Interestingly, feral cats that grow up without close human interaction often meow less in adulthood. This suggests that the behavior is reinforced through human response. In homes where vocal responses are acknowledged regularly, meowing tends to continue and refine. The pitch of a meow can also shift subtly based on urgency. Research has suggested that cats may add roughness or subtle variations to their vocal tone when seeking food, increasing the likelihood of response. These small changes may make the sound more attention-grabbing without becoming louder. Despite its clarity, a meow does not carry the same sustained rhythm as a purr. It is brief, a small interruption in stillness. Then it fades. The room returns to quiet. Because cats rely so heavily on body language, a meow is often only one part of the message. The body posture, the direction of gaze, and the timing all contribute to meaning. A meow at dawn may signal hunger. A meow at the door may signal curiosity. A meow while walking beside someone may signal companionship. The vocal cords vibrate. Air passes through. The sound travels across the space between cat and human. The nervous system of the listener interprets it. A response follows. A bowl is filled. A door is opened. A hand reaches down to stroke fur. In this way, the meow becomes part of shared daily life. It is not wild or urgent. It is familiar. A thread woven into routine. And as the sound fades into the air once more, the room grows quiet again. The small predator that rarely meows to its own kind continues to speak gently in a language shaped by years of living beside humans. Let the image of the quiet house cat widen slightly now. The room remains still. The floor, the walls, the soft furniture all remain in place. But imagine the scene stretching backward through time. The same body shape, the same eyes, the same flexible spine. Only the surroundings begin to change. Long before couches and doorways, the ancestors of today's house cats moved through dry grasslands and rocky desert edges in the Near East. Genetic studies show that domestic cats descended from the Near Eastern wildcat. The bones of early wildcats and modern house cats are remarkably similar. The structure of the skull, the shape of the teeth, the length of the limbs, very little has changed. Unlike dogs, which went through dramatic physical transformations during domestication, cats experience minimal skeletal change. Their bodies remain built for hunting. The forward-facing eyes still allow depth perception. The retractable claws still preserve sharpness. The flexible spine still supports powerful leaps. The domestic cat is not a heavily altered animal. It is a lightly adapted one. It is believed that cats likely began living near humans through a process sometimes described as self-domestication. Early agricultural communities stored grain, and where grain was stored, rodents gathered. Wildcats, drawn by the presence of prey, moved closer to human settlements. Over time, those wildcats that tolerated human presence gained easier access to food. Humans, in turn, may have benefited from reduced rodent populations. This arrangement did not require formal taming at first. The relationship formed gradually. Wildcats that were less fearful of humans were more likely to remain near settlements. Over generations, this tolerance increased. Social behavior shifted slightly. Aggression toward humans decreased in some individuals, making coexistence easier. Archaeological findings support this timeline. A burial site in Cyprus dating back about 9,000 years included a human and a cat interred together. Because cats were not native to Cyprus, this suggests that humans intentionally brought them there. The bond had already formed. Despite this long companionship, hunting instincts remain strong in domestic cats. Even well-fed indoor cats may stalk, pounce, and chase small moving objects. The sequence of crouch, focus, leap, and capture is deeply embedded in their nervous system. These patterns are not taught by humans. They are inherited. If you watch a cat track a moving toy across the floor, you can see echoes of ancient behavior. The body lowers into a crouch. The tail flicks lightly. The eyes narrow in concentration. These actions mirror those of their wild ancestors watching prey in tall grass. Yet alongside this hunting design, another trait slowly expanded over time: social tolerance toward humans. Wildcats are generally solitary. Domestic cats, while still independent, show greater flexibility in social settings. They can share space with humans and sometimes with other cats. They can adapt to predictable feeding times and indoor environments. Research into feline domestication suggests that changes occurred primarily in behavior rather than in physical form. Genes linked to temperament and social response shifted subtly across generations. These changes allowed cats to remain close to humans without losing their fundamental structure. The result is an animal that carries two layers at once. The ancient hunter remains present in muscle and bone. The domestic companion exists in behavior and tolerance. When a cat rests quietly beside a person, these layers overlap. The flexible spine built for sprinting lies folded against fabric. The eyes designed for dusk watch the gentle movement of a room. The claws remain sharp but hidden. The environment has changed from desert grass to indoor flooring, from open sky to ceiling light. Yet the body remains largely the same. Over thousands of years, the wild and the domestic have not replaced each other. They have settled side by side. The hunting instincts remain ready, even if rarely used. The tolerance for human presence has grown, even if independence remains strong. And so, in the quiet of a modern home, the shape of the ancient landscape still lingers within the small body of a house cat. The wild and the familiar rest together, breathing softly in the same room. Picture a quiet room once more. The air is still. Light rests softly across the floor. Then, something small shifts. Perhaps it is a faint shadow moving across a wall. Perhaps it is a rolling object, nudged gently by a passing hand. The cat notices. The body changes almost instantly. The head lowers slightly. The eyes fix on the movement. The ears angle forward. The tail begins a slow, controlled sway. This is the beginning of play, but beneath the surface, it follows a pattern much older than toys or indoor floors. Playing cats closely mirrors the hunting sequence. In the wild, hunting follows a clear progression: orient, stalk, chase, pounce, capture. Even in a safe home environment, this sequence remains built into the nervous system. A small moving object triggers the same internal script. When a cat locks its eyes onto a shifting shadow, the brain begins processing motion and distance. Forward-facing eyes allow depth perception, helping judge how far away the object is. The body lowers into a crouch. Muscles gather tension. The spine curves slightly. The fast twitch muscle fibers that power short bursts prepare once again for release. During moments of novelty, the brain releases dopamine, a chemical associated with reward and motivation. Dopamine encourages engagement. It sharpens focus. When a new object enters the environment or an old toy moves unpredictably, dopamine levels may rise slightly. The cat becomes attentive, alert, but not necessarily stressed. If the object rolls across the floor and disappears behind furniture, the cat does not simply forget it. Cats demonstrate object permanence. This means they understand that an object continues to exist even when it is out of sight. The cat may walk slowly to the place where the object vanished, sniffing and searching. The mental map of the room updates. The pounce itself is brief. The hind legs extend powerfully. The front paws reach forward. The claws may extend just enough to grasp. Then the motion ends. The toy lies still. The body relaxes almost as quickly as it activated. These bursts of activity are short for a reason. The fast twitch muscle fibers that power pouncing generate strength quickly, but fatigue faster than endurance muscles. After a short chase or leap, the cat often pauses. Breathing slows. The body settles. Energy is conserved again. Play also improves coordination. Kittens especially benefit from repeated practice. Jumping, turning mid-air, adjusting balance. These movements strengthen muscles and refine reflexes. Even adult cats maintain these skills through occasional play. The nervous system stays tuned. If you observe a playful cat closely, you may notice exaggerated movements. A sideways hop, a quick turn, a sudden freeze. These actions help simulate unpredictability, preparing the body for real-world challenges that may never come inside a home. After the pounce, grooming may follow, or a stretch. The sequence of movement and stillness repeats. Short activity, then rest. Short focus, then relaxation. Curiosity is closely tied to this pattern. When a new object enters the environment, the cat approaches slowly. The whiskers angle forward. The nose samples scent. The ears rotate toward faint sounds. The brain gathers information from multiple senses before deciding whether to engage. Novelty does not always require speed. Sometimes curiosity appears as stillness. The cat sits quietly, studying. The eyes track. The tail remains steady. Only when the moment feels right does motion begin. This balance between attention and rest reflects the cat's design. The body is built for efficiency. It does not waste energy in long pursuits. It waits, acts, and then recovers. In a quiet home, play may look simple. A toy on a string, a small object sliding across the floor. But within that simplicity lies a structured pattern rooted in ancient hunting behavior. The crouch, the leap, the capture, all practiced without necessity. And after the quick motion fades, the body returns to calm. The spine softens. The paws rest quietly once more. Energy has been spent in a brief, focused burst. Now it is restored, ready again for the next small movement that catches the eye before settling back into stillness. Visualize a simple cardboard box resting on the floor. It is not large. Its edges are plain. There is nothing special about it from a human perspective. And yet, before long, the cat has folded itself neatly inside. The body curves inward. The spine bends gently. The paws tuck beneath the chest. The tail wraps close to the side. Even if the box seems slightly too small, the cat adjusts, compressing into the available space with surprising precision. One reason cats are drawn to boxes relates to temperature. A cat's preferred ambient temperature is higher than that of most humans. Research suggests that cats are most comfortable in environments ranging roughly from 30 to 38 degrees Celsius. Most homes are kept cooler than this. A box, especially one made of cardboard, can help trap body heat. The enclosed space reduces airflow and retains warmth. Cardboard itself acts as an insulator. It slows the loss of heat from the body. When a cat curls inside a box, its body heat warms the interior air. Because the walls of the box limit movement of that air, warmth stays concentrated around the cat's body. The result is a small pocket of comfort. Beyond warmth, enclosure appears to reduce cortisol levels in cats. Cortisol, the stress hormone, rises when animals feel uncertain or exposed. In open spaces, a cat must remain alert to multiple directions at once. In a confined space with clear boundaries, the environment becomes more predictable. There are fewer angles to monitor. The nervous system can settle. The instinct to seek concealment traces back to wild ancestry. In natural settings, small predators often use hidden vantage points to observe prey without being seen. Tall grass, hollow logs, or rocky crevices provide partial cover. A box in a modern home may function as a simplified version of these natural hiding places. Inside the box, the edges define clear limits. The walls create boundaries that the cat can feel against its sides. This physical feedback enhances body awareness. The shape of the space supports the curve of the spine. The shoulders relax into the edges. The paws press lightly against the bottom. Clear boundaries can feel predictable and safe. When a cat can touch the walls of a space without being fully exposed, it maintains both security and awareness. The head may rest near the opening, allowing observation of the room while the body remains protected. You may notice that even shy or anxious cats are more likely to approach new environments if boxes or enclosed spaces are available. Studies in shelter environments have shown that cats provided with hiding boxes often adjust more quickly. The enclosed space allows them to regulate stress while still participating in their surroundings. The box does not need to be soft or elaborate. It does not need decoration. Its appeal lies in structure, the flat surfaces, the right angles, the contained air. When a cat steps into a box, it often circles once or twice before settling. This circling helps adjust the body to fit the dimensions of the space. The spine curves, the tail tucks, the shoulders lower. The fit becomes precise. Even if the box seems smaller than the cat's body, flexibility allows adaptation. The same spine that supports powerful leaps can compress comfortably. The hind legs fold inward, the head lowers slightly, the ears remain alert but relaxed. Inside the enclosure, external stimuli soften. Sounds become slightly muted. Movement outside the box remains visible through the opening, but the walls block peripheral distraction. The nervous system shifts into a calmer state. Sometimes a cat will choose a box over a more comfortable bed. From a human perspective, this may seem puzzling. But comfort is not defined only by softness. It is also defined by temperature, containment, and predictability. As the cat rests within its small boundary, breathing slows. The body heat gathers. The world outside feels slightly distant. The edges of the box hold steady around the curved shape of fur and muscle. And within those simple walls, a quiet sense of safety settles. The space is small, but it is complete. The boundaries are clear. The air is warm. The body rests contained and calm. Consider the subtle timing between a person and a cat living in the same home. The day begins quietly. Light shifts through the window. A person moves from room to room. Somewhere nearby, the cat adjusts as well. Over time, cats learn regular feeding schedules. Even without clocks, they become highly sensitive to patterns. The sound of footsteps at a certain hour, the movement toward a particular cabinet, the faint rattle of a food container. These repeated cues build expectation. The brain begins to anticipate the event before it happens. When feeding occurs at consistent times, the cat's internal rhythms gradually align. The digestive system prepares. Activity may increase shortly before the expected meal. This anticipation is not random. It reflects the cat's ability to detect and memorize routine. Cats often synchronize portions of their sleep patterns with humans. While they are naturally crepuscular, active at dawn and dusk, many adjust their rest cycles slightly to match household activity. If the home becomes quiet at night, the cat may rest more deeply during those hours. If morning movement begins early, the cat may shift its active window forward. This flexibility shows that while ancient rhythms remain present, adaptation is possible. The nervous system responds not only to sunlight, but also to social cues. Cats also recognize familiar human voices. Studies have demonstrated that cats can distinguish their owner's voice from that of strangers. They may not always respond visibly, but subtle changes occur. The ears turn, the head lifts slightly, the tail flicks once. Recognition does not always require dramatic movement. Interestingly, cats tend to respond more to tone than to specific words. The pitch and emotional quality of a voice carry more meaning than vocabulary. A gentle tone often produces calm behavior. A sharp tone may cause the ears to angle back slightly. Over time, cats learn the emotional patterns embedded in speech. Social referencing behaviors have also been observed in cats. In unfamiliar situations, some cats glance toward their owner to gauge reaction. If the human appears calm, the cat may remain calm as well. If the human reacts with tension, the cat may become more alert. This subtle checking behavior indicates awareness of social context. Shared routines strengthen these connections. When a person sits down each evening in the same chair, the cat may begin to approach at that time. The body learns the rhythm of the household. Movement becomes predictable. Predictability lowers stress. If you watch closely, you may see small synchronizations throughout the day. A cat may follow someone from room to room without demanding attention. It may rest in the same space where work is being done. The body aligns not through constant interaction, but through quiet presence. Cats are often described as independent, and they are. But independence does not exclude awareness. The small adjustments in timing and behavior reveal a subtle form of companionship. Even sleep can overlap. A cat may choose to rest near a person during quiet hours. Breathing rhythms may gradually align. The steady rise and fall of one body occurs beside the steady rise and fall of another. Feeding times, play sessions, moments of stillness, all contribute to a shared structure. The cat learns when doors open, when lights dim, when voices grow soft. The synchronization does not require training. It emerges gradually through repetition. Each day reinforces the next. The brain builds expectation from pattern. Over time, the house becomes more than territory marked by scent. It becomes a space shaped by shared routine. The cat's movement intersects with human movement in quiet ways. As evening settles and activity slows, the rhythms merge again. The person rests. The cat curls nearby. The day's pattern concludes without announcement. Within that steady repetition, something almost unnoticed takes shape. Not dependence, but alignment. Not command, but recognition. A shared timing that softens into background comfort, steady and familiar as breath. Even in a calm home, the body of a house cat carries an ancient balance within it. It is both predator and prey. This dual role shapes how sensitive cats can be to their surroundings. In the wild, a small predator must remain alert not only to what it hunts, but also to what might hunt it. Larger animals, sudden noises, or unfamiliar movement could pose danger. This prey-predator balance built a nervous system that scans the environment carefully. Even indoors, where true threats are rare, that sensitivity remains. You may notice that a cat resting in a quiet room still keeps one ear slightly angled toward sound. The eyes may close but not fully. The body relaxes, yet awareness lingers beneath the surface. This is hypervigilance in a mild form. It is not fear, it is readiness. Routine plays a powerful role in lowering stress hormones. When daily patterns remain consistent, the nervous system does not need to stay on high alert. Feeding at regular times, predictable movement through the home, and stable lighting cues all help reduce cortisol levels. The body learns that nothing unexpected will happen. When routine changes suddenly, the effect can be noticeable. Moving furniture, introducing new scents, loud construction sounds, or travel can trigger cortisol spikes. cortisol prepares the body for action. Heart rate may increase slightly. Muscles may tense. The cat may hide or groom more frequently. Environmental change does not need to be dramatic to cause a response. Even subtle shifts in scent can alter behavior. Because cats rely heavily on smell to define territory, the introduction of unfamiliar odors can feel like a disruption of their invisible map. Subtle body cues often signal discomfort long before overt signs appear. A cat experiencing stress may narrow its eyes slightly, flatten its ears, or hold its tail lower than usual. The body may become more rigid. Grooming may increase in a focused area. These signals are quiet but meaningful. Whiskers also provide information about emotional state. Under stress, whiskers may angle forward or become more rigid. The small muscles at the base of each whisker respond to changes in arousal. When relaxed, whiskers rest softly outward. When alert or tense, they may shift position. The whiskers themselves are deeply connected to sensory input. Each whisker sits in a follicle rich with nerve endings. They detect subtle changes in air movement and space. In tight environments, whiskers brush against surfaces, providing feedback about boundaries. When a cat feels overwhelmed, it may retreat to an enclosed space, such as a box or under a bed. The reduction of visual input and containment of space helps regulate stress. The body seeks predictability. Because of this sensitivity, small adjustments in environment can have meaningful effects. Providing vertical spaces, quiet hiding spots, and stable routines supports emotional balance. The nervous system remains responsive but not overwhelmed. Hypervigilance does not mean constant fear. It means the system is finely tuned. It can shift quickly from calm to alert if needed. But in a stable home with consistent cues, that shift rarely occurs. You may see a cat resting deeply, yet still respond instantly to the faint sound of a treat bag. The ears rotate, the head lifts, the body engages. Then, once the moment passes, relaxation returns. This ability to move between states quickly is part of the feline design. The stress response activates when necessary, then subsides when safety is confirmed. Over time, in environments where routine holds steady, cortisol levels tend to remain lower. The body conserves energy rather than preparing constantly for threat. And so, within the walls of a home, the small predator with ancient reflexes learns that most days carry no danger. The ears soften, the whiskers relax. The body rests more fully. Sensitivity remains, but it no longer dominates. It settles quietly beneath the surface, present but calm, balanced gently between awareness and ease. Time moves quietly in a house where a cat lives. Days blend into one another. Light shifts across the same floors. Familiar routines repeat, and slowly, almost without notice, the cat grows older. The average lifespan of an indoor house cat ranges between 12 and 18 years. Some live even longer with attentive care and stable environments. Indoors, cats are protected from many risks that outdoor cats face, such as traffic, predators, and disease exposure. This safety allows the body to age gradually rather than abruptly. As cats grow older, metabolism begins to slow. Metabolism refers to the rate at which the body uses energy. A younger cat may burn calories more quickly and move more frequently throughout the day. An older cat may conserve energy more carefully. Appetite can change. Body weight may shift slightly, either increasing or decreasing, depending on health and activity levels. Sleep often increases with age. While adult cats already sleep between 12 and 16 hours per day, senior cats may sleep even longer. The bursts of activity become shorter. The intervals of rest grow longer. This is not laziness. It is a natural adjustment as muscle mass gradually declines and energy reserves are managed more conservatively. Joint stiffness becomes more common in aging cats. Over time, cartilage within joints can wear down. The smooth surfaces that once allowed easy movement may become less flexible. You might notice a senior cat hesitating before jumping onto a favorite surface. The leap may be lower, the landing more cautious. Because cats are skilled at hiding discomfort, joint stiffness can go unnoticed at first. Subtle signs include slower rising from rest, reduced grooming of harder-to-reach areas, or decreased interest in climbing. The body adapts quietly. Dental disease is also frequent in older cats. Plaque and tartar can build up over time, especially if regular dental care is not provided. Gum inflammation and tooth decay may develop gradually. Because cats do not often show obvious signs of oral pain, dental issues can progress without dramatic symptoms. A slight change in eating habits or preference for softer food may be an early indicator. Despite these changes, many senior cats maintain a strong sense of routine. The mental maps of their home remain detailed. Familiar paths are followed. Favorite resting spots continue to provide comfort. Stability becomes even more important as physical resilience decreases. Vision and hearing may shift subtly with age, though many indoor cats retain these senses well into later years. Even if sensory acuity declines slightly, familiarity with the environment reduces stress. The cat knows where the furniture stands. It knows the pattern of daily movement. You may observe that older cats groom themselves a bit less thoroughly. Reduced flexibility and joint stiffness can make certain areas harder to reach. Gentle assistance from a human caretaker can help maintain coat health. Behaviorally, senior cats often become calmer. Play still occurs, but less frequently and with less intensity. The dopamine bursts associated with novelty may still activate, but the response may be slower and shorter. Warmth becomes increasingly appealing. Because metabolism slows and muscle mass decreases, maintaining body temperature requires more energy. Sunlit patches on the floor or soft blankets become favored locations. The body curls inward to conserve heat. In many ways, aging indoors allows for a softer transition through time. The wild demands of survival are absent. There is no need for constant hunting or territory defense. The small predator built for bursts of speed can settle into longer stretches of rest. Yet even in advanced age, familiar behaviors remain. A slow blink, a quiet purr, a gentle brush against a doorway. The years pass, but the essential structure stays recognizable. The flexible spine may move more slowly. The leaps may shorten. The sleep may deepen. Within the steady walls of a home, aging unfolds without urgency. The rhythms soften. Movement becomes deliberate. Rest becomes longer. And in that quiet progression, the house cat continues to share space gently, carrying its years with calm acceptance, resting where warmth and familiarity remain close at hand. There is a moment that happens quietly between a cat and a person. No sound is made. No movement breaks the stillness of the room. The cat looks toward you. Its eyes are open but soft. Then slowly the eyelids lower halfway, pause, and rise again. This is often called the slow blink. In feline communication, direct, unbroken eye contact can signal intensity. Among animals, a hard stare may indicate threat or challenge. Because of this, relaxed cats often avoid prolonged, rigid eye contact with one another. Instead, they soften their gaze or look away slightly to reduce tension. The slow blink appears to function as a non-threat signal. When a cat slowly narrows its eyes in your direction, it is not disengaging. It is communicating calm. The muscles around the eyes relax. The eyelids lower gradually rather than snapping shut. The expression is loose, unforced. Research has shown that cats respond to human slow blinking. In controlled studies, when a person slowly narrows their eyes toward a cat and softens their facial muscles, cats are more likely to approach and respond positively. The behavior seems to create a shared signal of safety. The key lies in reducing eye contact intensity. Instead of a direct, fixed stare, the eyes soften and partially close. This lowers the perceived level of alertness or threat. In animal communication, reducing tension through subtle gestures helps maintain peace within shared space. If you try this gently, meeting a cat's gaze softly, then slowly narrowing your eyes and holding that relaxed expression, you may notice a response. The cat may return the blink. It may turn its head slightly. It may approach or simply remain calm. The muscles involved in this behavior are small but expressive. Around the eyes are fine facial muscles that shift with emotion. In a relaxed state, these muscles ease. The whiskers rest outward rather than forward. The ears remain neutral. Because cats are sensitive to tone and posture, the slow blink is often paired with stillness. Sudden movement can disrupt the signal. Calm breathing, soft shoulders, and steady posture support the message. Mutual blinking appears to increase bonding. When both human and cat exchange this gesture, the nervous systems of both may shift toward a calmer state. The interaction is brief but meaningful. In contrast to vocalizations like meowing, the slow blink requires no sound. It is silent communication. It does not demand attention. It offers reassurance. The eyes are powerful sensory organs. They gather light, track motion, and assess distance. Yet they also carry social meaning. The narrowing of the eyes reduces visual sharpness slightly. The cat does not need to focus intensely on the environment in that moment. Alertness decreases gently. In homes where trust is well established, slow blinking may occur frequently during quiet times. A cat resting on a couch may glance toward a nearby person and perform the gesture almost absent-mindedly. The room remains peaceful. It is not submission. It is not surrender. It is an expression of comfort. Because cats evolved with heightened sensitivity to visual cues, subtle shifts carry weight. A relaxed blink can signal more than a loud call. It tells the other being in the room, I am not a threat. I am calm. When humans respond in kind, the exchange deepens. The shared rhythm of softened eyes becomes part of daily routine. No dramatic movement follows. The cat may return to resting. The person may continue their task. But in that brief narrowing of the eyelids, something quiet passes between them. A small agreement of peace. A mutual understanding carried not in words, but in stillness. If you sit quietly beside a house cat for a few minutes, you may begin to notice something subtle happening inside your own body. The room feels steady. The air feels softer. The movements around you slow down, even if nothing dramatic has changed. House cats often feel calming to be around, and part of that effect can be explained by simple biology. Many of a cat's behaviors are repetitive. Grooming follows a steady rhythm. Kneading moves in alternating patterns. Purring maintains a continuous vibration. Even the rise and fall of sleep follows predictable cycles. Repetitive motion has a regulating effect on nervous systems, not only in cats but in humans as well. When a movement repeats in a steady, predictable way, it signals safety. There is no sudden shift, no abrupt change. The sound of purring plays a role here too. As we discussed earlier, the frequency of a typical purr falls between about 25 and 150 Hz. These low, steady auditory frequencies are not sharp or piercing. They are soft and consistent. Sounds in this range can reduce alertness rather than increase it. They do not demand immediate reaction. Human nervous systems are highly responsive to sound. A sudden, high-pitched noise can trigger a quick stress response. In contrast, a low, repetitive vibration tends to encourage relaxation. The body does not interpret it as threat. Instead, breathing may gradually slow. Muscles may release tension. Predictable movements also reduce vigilance. When you watch a cat move slowly through a room, there is rarely anything abrupt about it. The steps are measured. The tail shifts gently. The ears rotate with small adjustments. Even when a cat stretches, the movement unfolds gradually. The human brain constantly scans for unpredictable motion as a way of detecting potential danger. When the environment remains steady and predictable, that scanning decreases. Sitting near a calm animal that moves in smooth, unhurried ways can subtly influence this process. Warmth contributes as well. A cat's average body temperature is around 38 degrees Celsius, slightly warmer than a human's. When a cat rests against your leg or curls on your lap, that warmth transfers gently. Warmth can encourage blood vessels near the skin to expand slightly, promoting relaxation. It also signals comfort and safety at a basic physiological level. There is also the phenomenon of nervous system mirroring. Humans often mirror the emotional states and rhythms of those around them, sometimes without realizing it. When another being breathes slowly and remains calm, our own breathing may adjust. When the environment holds steady, internal tension may soften. The steady rise and fall of a sleeping cat's chest can act almost like a visual metronome. Watching it can guide your own breathing into a slower rhythm. The soft sound of purring can become background noise that masks sharper, more stimulating sounds in the room. Unlike screens or devices that flash and shift rapidly, A cat resting nearby offers a simple, continuous presence. The eyes may close slowly. The body remains contained. There is no sudden demand for attention. Even small gestures, like the slow blink, reduce intensity in shared space. Eye contact softens. The atmosphere shifts toward calm. It is important to note that this calming effect is not mystical. It arises from predictable biology. Repetition regulates. Warmth relaxes. Soft sound lowers alertness. Steady motion reduces the need for constant vigilance. Over time, simply sharing space with a calm animal can create an association between that presence and safety. The body learns that when the cat is relaxed, the environment is stable. And so, as the cat curls into its usual place and breathes quietly, something inside you may match that pace. Shoulders lower, breathing deepens, the mind quiets slightly. Without effort, without instruction, the steady rhythms of the house cat shape the room around it. And in that shaping, calm spreads gently outward. The room is quiet now. Somewhere nearby, a small body is curled into itself. The spine that can stretch and leap rests softly against fabric. The paws that once pressed in slow, kneading rhythm are still. The whiskers lie gently outward. The ears no longer rotate toward every faint sound. The house cat, built from ancient instinct and modern comfort, breathes in and out without hurry. Over these past hours, we've moved through the details of that small body. The missing sweetness gene that shapes its taste, the flexible spine that powers its jump, the purr that hums through inhale and exhale, the grooming that regulates, the slow blink that signals trust, the invisible scent lines that map a home, the way routine lowers stress, the way warmth and repetition calm both feline and human nervous systems. And yet, when you look at a resting cat, none of that complexity feels loud. It feels simple. A quiet weight beside you, a steady rhythm in the background, a presence that does not demand conversation or explanation, just shared space. The wild and the domestic live together in that stillness. The hunter sleeps, the companion remains. The ancient reflexes soften into a modern room filled with familiar walls and gentle light. If your eyes are growing heavy now, let them. Picture the slow rise and fall of breath, the faint vibration of a purr, the warmth of a small body tucked close to itself. Let the edges of the room feel stable and predictable, like the boundaries of a well-loved box. There is nothing to chase, nothing to calculate, no sudden movement to track, only quiet. Thank you for spending this time here on Science for Sleep. If you'd like to return again, you're always welcome. And if there's a place in the world where you're listening from tonight, you can share it below. For now, let the rhythm continue without effort. Let your breathing settle into something slow and even. Let the room hold you the way a familiar home holds a resting cat. And allow the quiet to deepen gently into sleep.